It says Kay grows and sells tomatoes and green beans. It costs $1 to grow a bushel of tomatoes, and it takes 1 square yard of land. It costs $3 to grow a bushel of beans, and it takes 6 square yards of land. Kay's budget is $15, and she has 24 square yards of land available. If she makes $1 profit on each bushel of tomatoes and $4 profit on each bushel of beans, how many bushels of each should she grow in order to maximize her profit? So when it says bushels of each, we want to keep in mind that this is both beans and tomatoes. I'm going to put tomatoes and beans. That's what this means. It's both of them. That's what each. How many bushels of tomatoes and how many bushels of beans should she grow in order to maximize her profit? So that means to make the most money. Okay? We want to make the most money possible when she's growing and selling her vegetables. That's going to be our end goal here. So we're going to have a couple steps to figure that out. It says we have 2 variables. Before we start, we need to define them. So the 2 things that she's growing that we're looking at here are tomatoes and beans. Those are the 2 things that we're looking at when we are going to be solving this and trying to figure out how much of each she should grow to make the most money. Okay, so X is going to represent tomatoes and Y is going to represent beans from now on. So I'm going to go to slide 2. Now that we have our variables, let's get our restraint equations. Restraint equations are equations that are going to restrict us to real life consequences. So let's get into that. I know there's a lot of words on here. This is all the same problem. Okay, it's just the word problem again. So let's start here. There are 2 constraints that we have to know. For example, can we grow negative beans? Can you say can you say that we have -2 beans? Would you say that? No, we would say I have one bushel of beans, 2, 3, 4, they're whole numbers greater than or equal to 0. Same thing for tomatoes. We can't have negative tomatoes. So this means that we have to define our variable constraints to be greater than or equal to 0. So I'm going to start here with my tomatoes. So remember, tomatoes is my X, has to be greater than or equal to, and you can get that symbol here where it says greater than or equal to. You can click right there, 0. And then my beans also have to be greater than or equal to 0. And remember, we said X is tomatoes and Y is beans. So this says tomatoes are greater than or equal to 0, beans are greater than or equal to 0. Okay, we just putting the letters to simplify it a little bit. Okay, we're going to press submit. Then it says constraint number 1. This is our cost constraint because she has a budget. She doesn't want to spend more than $15. But it costs $1 to grow a bushel of tomatoes and $3 to grow a bushel of beans. So I'm going to put 1x because it costs $1 to grow a bushel of tomatoes. And remember, tomatoes was X. Plus, it costs $3 to grow a bushel of beans. So 3y. Okay. And I don't want to spend more than $15. When you have a budget, you want to keep it to less than or equal to $15. Okay. That's our cost constraint. We don't want to spend more than $15, but it costs money to actually buy the seeds and take care of it and make them grow. Okay. Our second constraint is our land. Think about it. If you have a certain amount of land, you can't just grow your plants wherever you want to. You have to stay within your land. So it takes 1 square yard of land to grow tomatoes. So again, tomatoes is X. I'm going to put 1x, 1 square yard for tomatoes, plus 6 square yards for beans. So again, 6y. Remember, my y is my beans. X is tomatoes, y is beans. Again, I don't want to go over this 24. I want to stay under that, so less than or equal to 24. Okay? So now that we have all of our constraints, these are all of our inequalities, we're going to go ahead and graph them on slide 4. So I'm going to type them all in here. x is greater than or equal to 0. Y is greater than or equal to 0. Now, I don't really like that they're the same color, so I'm going to go ahead and change this one to blue. My third one was 1x plus 3y is less than or equal to 15. 1x plus 3y is less than or equal to 15. Right, and my last one is 1x plus 6y is less than or equal to 24. 1x plus 6y is less than or equal to 24. All right, so I'm going to change some colors here. This one I'm going to make green, and this one I'm going to make, let's do orange. Okay, again, how I did that with the colors, I clicked right here, and then you click on the color, and you can change it. Okay, you can change it to whatever you want to. Click done. So now I'm going to drag this over so I can see. The directions said graph all 4 constraints. I just did that. It says be sure to show your feasible region and clearly label coordinates of the vertices. Okay, so my corners of my vertices I have here. So my feasible region is where I have all of the colors. So my red, blue, green, and purple is in this area. This section right here has all of the colors, okay? Up here you have purple, oh, not purple, sorry. It looks like you have blue and red here. It looks like over here you have blue and green and some orange. Down here I think it's just orange. You have orange and red. But here in this shape, okay, you have, we have all 4 of the colors, okay? So I want all the vertices, okay? So I want all of the numbers that, there's 4 numbers that make the shape of this. So there is my shape, okay? Those numbers are going to be important on our next slide. That helps us find a maximum or a minimum. So 0, 4, 6, 3, 15, 0, and 0, 0. That will come in handy on our next slide. Okay, so let's figure out her profit. She makes $1 profit on each bushel of tomatoes and $4 profit on each bushel of beans. So I'm going to write, remember, my tomatoes is X, so 1X plus 4Y. That's my profit equation. So for every bushel of tomatoes, we're going to have $1, and for every bushel of beans, we're also going to have another $1. Click submit, make sure you press this button, because then it will say, are we looking for the maximum or minimum value? And if we look at our question here, it says how many bushels of each should she grow in order to maximize profit? So I'm looking for a maximum. Okay, so in order to maximize profit, I'm going to look at all of my corner points. These were all 4 of those points from here. 0, 0, 0, 4, 6, 3, and 15, 0. Those 4 points are what are here. So I'm going to plug them into my profit equation. So what happens if I make 0 tomatoes and 0 beans? So I have 1 times 0, or I'm going to write it like this. It's 1x plus 4y. So what I do is I delete my x, and I'm going to put 0 in for x, because that's my x coordinate, and 0 in for y, because that's my y coordinate, and I'm just going to hit enter, and it gives me 0. If you make if she grows 0 tomatoes and 0 beans, she's going to make $0. So let's do it here. $1 for her 0 tomatoes here, plus $4 for her 4 beans, and she will make $16. Okay, let's see here if she makes $1 for her 6 tomatoes, plus $4 for her 3 beans, she will make $18. And lastly, for her $1 that she makes for 15 tomatoes, plus $4 for no beans, she will make $15. Which coordinate maximizes the profit equation? So which point gives us the greatest profit? So I look at my values, 0, 16, 18, and 15. Okay, which one is the biggest? I see here 18 is the biggest. So that's 6, 3. Okay, it says, great job. Now fill in the blanks with your results to complete the sentence. In order for Kay to maximize her profit, she should grow blank bushels of tomatoes. So which one is tomatoes? Was that my X or my Y? And that's my X. X is tomatoes, so 6 bushels of tomatoes, 3 bushels of beans, and that will make her a profit of $18, which is her highest profit of all of her options. And that is your final answer. Feel free to go back in this video and rewatch and email me or ask me any questions if you are stuck on any of this. But that is all the same steps you will follow for your own problem. Thanks for watching.